The next key term which we're going to discuss is about POS. We call it as part of speech tagging. So basically, part of speech tagging aims to identify which grammatical group a word belongs to, whether it's a noun, adjective, verb, adverb, etc. This means it looks for the relationship within the sentence and gives each word in a sentence the corresponding tag. The important key term, dependency parsing. Actually, it's a technique used to identify the semantic relationship between words in a sentence. We already break down the sentence into multiple words. Now we are going to find the relationship between the words. So this parser is used to map the words in a sentence to semantic roles, so thereby identifying the relationship between the words. There are various tags used to represent the relationship between the two words in a sentence. For example, here you can see the root word prefer. So prefer what? Prefer flight, prefer what? So the morning is related to flight. Then you can see multiple relationship here in the given example. Chunking is also one of the important processes in NLP, which is used to identify the part of speech are the short phrases. In other simple words, we can say chunking always works on top of POS tagging. It's a partial parsing. So it's basically chunk patterns. We find patterns in the given sentence and words. And like what kind of word should not be in the chunk, what should not be chunked, or what should be chunked, all can be categorized here. Interestingly, this process of chunking in NLP also extended to various other applications. For instance, if you want to group fruits of specific categories, say like fruits rich in protein as one group and fruits rich in vitamins as other group, and so on, we can do that using chunking. So besides, chunking can also be used to group similar cars, say cars supporting auto gear in one group, and the others which support the manual gear into another chunk, and so on. Actually, there are different types of chunking which we'll be discussing in later part. We call it as chunking up, chunking down, and all these are. Lemmatization is also one of the important pre-processing technique in NLP. So it's very simple. It's a process of converting the words into their base forms. For example, you're having a data set where you can see multiple words. Starts with leaves, LEAFS, something similar. But after we lemmatize, we just take out one word, that is LEAF. So whatever you see as leaves will be like transformed, changed to leaf, to the base form. So this is lemmatization. So this helps to map the multiple words into a common root word. So this way the words are treated similarly, and the model will learn that they can be used in similar context. Stemming is also one of the important technique in NLP, which is used to extract the base form of the word by removing the affixes. Prefix means which comes before, affix means which comes towards the end. So basically it's a process to remove the last few characters from the word. Often it's like leading to the incorrect meaning and spelling. So usually we consider lemmatization instead of stemming, but sometimes we also need to do stemming. Stemming is like straightforward to implement and fast to run, but there might be some inaccuracies. Sometimes the words might be irrelevant for the task, like that, like text indexing, all these. If there's a question like stemming or lemmatization, which one is good? When are we supposed to use this? So the answer is very simple. Stemming is a faster process than lemmatization, and irrespective of the context. Whereas lemmatization has high accuracy than stemming. So it depends on the scenario, what is the problem statement. So you can choose stemming or lemmatization accordingly. Named entity recognition, we call it as NER, is also one of the pre-processing technique. Actually, if we look at this example sentence, I hear Berlin is wonderful in the winter. So Berlin is a place and winter is a season. When we read this in English, we understand as a human. So how are we going to make the machines to understand that this is a place and winter? So using named entity recognition, we can do that. And moreover, it's like if you're working with a big data where a lot of text is involved, so it's very easy, and NRE becomes essential to improve the performance. And normally NRE have 8 categories. I didn't mention it here, but later part we are going to see that as well, like location, person, organization, date, time, percentage, monetary value, and also the none of the above is also included. So we can use all these, and it works by locating and identifying the named entities present in the unstructured text into the standard categories. So any country names like Malaysia, Singapore, all these comes under places, a country. Alright. Stop word removal is also one of the most commonly used pre-processing across different NLP applications. The idea is simple, removing the words that occur commonly across all the documents in the corpus. Corpus is nothing but the document. So why stop words should be removed? Because stop words are available in abundance in any human language, like question mark, exclamation, hyphenated words, a double quotation, all these are. By removing these words, we remove a low-level information from our text in order to give more focus to the important information. Okay, now we are in the end of the theory part, which is necessary for doing the basic NLP lab session week 1 and week 2. Thank you so much.